Welcome everyone to German Tool Reviews. Today we have another vintage West German power tool. This time it is an AEG KS1.6 sheet metal shears. I've really become a big fan of these AEG power tools. There aren't many brands of power tools that you can say work great after 30 plus years. Let's go ahead and test this thing before cracking it open. As you can hear, the long spin down time indicates that the bearings in this unit are in very good shape. Taking a look at the specs on the label, this unit draws 300 watts and is capable of cutting 16 gauge with a shear force at 57,000 psi at 3,500 RPM. The yellow paint you see on this unit is something you often see on job sites or in workshops to mark your tools so you can easily identify them if somebody else has the same tool. This unit is a perfect candidate for restoration as it's mostly just a cleaning job. Alright, so let's tear down the unit. It's sort of odd how one of the screws holding the plastic housing is obscured by the handle guard. Therefore my first inclination is to take out the button head socket screw holding the guard. However, even my shortest L key did not have enough clearance to engage the screw. So let's go for another approach and take the cutters off first. There is a set screw that is used to adjust the position of the lower cutter. There looks to be some reusable blue thread locker applied. The lower cutter is attached with a socket cap screw and a standard hex nut. These were really gunked up with something. I'm guessing somebody was cutting something with labels on it and the adhesive gunked up. The upper blade was attached with a socket cap screw with a tapped hole on the unit. Next I took out this socket cap screw with the hopes that this would allow the unit to slide off. This screw was extremely tight and the only way I could get it off was using the Vera stainless long arm L keys. I normally like to reserve these just for stainless fasteners, but this was the only set of long arm metric keys I had. Note to self, get another set of long arm L keys to use on non-stainless fasteners. This socket cap screw is a pointed set screw that is often used to prevent rotation on the shaft, so this is probably not holding the head in place. At this point I decided to go ahead and remove the plastic cover. In order to pull the armature out, you should really remove the brushes in order to prevent chipping. I couldn't find an offset screwdriver, so the trick is to use the standard hex bit and a wrench. Opening the cover, we see a little bit of dust, but it's not too bad. On the inside cover here, you see a label with the marking 5-80, which I presume is for May 1980. I was quite surprised that this tool was this old, if that really is the manufacture date. That is really a testament to the quality of these West German AEG tools. Next, let's take out the brush holders and carbon brushes. They actually look to be in pretty good shape. Now we should be able to safely take off the gearbox. It is held in with 2 socket cap screws. Yeah, that is probably 35-year-old grease still in there. It was surprising to see underneath this gasket there were 4 additional slotted screws holding the lower half of the gearbox to the housing. This is not a design you often see. After taking out these 4 screws, the lower housing can be separated from the armature. The bearings in this unit are quite amazing. Look how smoothly this armature spins. Especially impressive for 35-year-old bearings. So we'll go ahead and punch the armature out, and then remove the main pinion. A small clip is used to hold the main thrust bearing onto the eccentric shaft. The pinion bearing is an NSK branded 636. NSK is a Japanese company that makes bearings primarily targeted toward the automotive industry. This is the first time I have seen this brand in a German tool. There are no markings on the thrust bearing. The armature bearing is an NTN bearing with type Z809. It is stamped West Germany on the side. Now we'll scrape out as much of the grease as we can from the gearbox. Inside we see a linkage attached to a shaft that moves the blade up and down. In order to remove this, we need to punch out this pin. After removing that linkage, the shaft will not totally slide out the end of the tool. It looks like we need to take out the entire cutting assembly. This is primarily what the socket cap set screw was holding in place. It was stuck, but a couple of hits with a hammer fixed that. Finally, with the cutting assembly out, we can take out the screw holding the handguard. We are now done disassembling the gearbox. Now back to the main housing. We will remove the cable clamp and the mains connections to the switch. Interesting how this tool is grounding the gearbox housing to earth ground. I wonder why some tool manufacturers do this while others don't, even though they both have exposed metal gearbox housings. The ground lug was tagged down with some thread locker, which made it a little bit more difficult to remove. The switch is a Marquardt brand style switch that we have seen before. There is also a date code of March 1980 on the switch, which confirms that the tool was manufactured in 1980. Next, we'll pull off the field windings. Nothing unusual or interesting about the field windings. Doesn't look like there should be any issues with using it as is. Then we can remove the ground wire, which was routed underneath the brush holder. The last component to remove is the switch assembly, which is held on with the Phillips flathead screw. Really nice to see a brass threaded insert here. The switch lever part is interesting because the metal switch rod is embedded into the plastic as part of the injection molding. I really hope this part never breaks, as it would be difficult to find and or make a replacement. Disassembling the switch, there doesn't appear to be any issues, just needs a standard cleaning of the contacts. So now that we have everything disassembled, it's time to start the restoration. I will put Amazon affiliate links in the description below to any consumables used for anyone that is interested. I got a tip on a YouTube comment about Barkeeper's Friend Cleaner. We'll give it a shot on some of these metal parts. Yeah, I would say it does an alright cleaning job. It definitely looks to be good for delicate parts as it is not an abrasive cleaner. Next, I want to strip all of the paint, including the factory silver, off the gearbox housing. My paint stripper of choice is this soybean-based product called Soy Gel. This is the only type of stripper that works on all paints that I've ever thrown at it. The good thing is that this stuff is not caustic and gives off no dangerous fumes. While the soy gel is working, we'll go ahead and soak the remaining metal parts in evaporust to remove just that small amount of corrosion. After about 45 minutes, we'll take a look at the paint stripper. Usually for stripping metal, I will just use a paper towel to remove the stripper and the paint, but a plastic scraper would probably work better. As you can see, the small portion of the gearbox housing is stripped of both the yellow and the silver paint after just one application. For the larger portion of the gearbox, the first application removed all of the yellow and a good part of the silver paint. A second coat of the soy gel was required because this probably had more than one layer of silver paint applied at the factory. The items in the evaporust bath were removed after about an hour. The only real spots of rust were two areas on the handguard, both of which we were able to remove. The remaining metal pieces were scrubbed. To make sure we get that paint off, after about an hour I used a stainless steel brush to remove the last of the paint. As you can see here, we were now down to bare aluminum. After cleaning off the remaining stripper, we can see why they probably painted the housing. There are quite a few casting imperfections on the exterior of the gearbox. Even after the paint stripper, you can still see a couple of stubborn spots of paint. To get these, and to hopefully remove the casting imperfections, I wet sanded the gearbox exterior. My polish of choice for aluminum has been this Blue Magic metal polish. If you want to get an almost mirror-like finish, then this is the stuff to use. I personally like the polished housing as opposed to a painted one. The upper and lower housings did polish differently, so I believe that there are two different aluminum alloys. Possibly one needs to be stronger than the other. I did try the Blue Magic on the steel handguard, but it didn't quite polish to the level that the aluminum does. However, I still think it looks good. Before we move on, I just wanted to point out the level of precision and time it must have taken to make some of these parts. The cast steel cutting head has both lathe and milling operations, as well as making a boring for a shaft hole and creating tapped holes. At the time this was made, I doubt they were using CNC machines, so it was probably just a few skilled machinists. Same thing for the main cutting shaft, not a single imperfection that I could see. Next, we'll clean up the plastic housings. After washing off the housings off camera, I used Novice number 2 to polish out the fine scratches. I used some 3000 grit sandpaper to clean the surface of the commutator. Now it's time to reassemble the gearbox. I used some 3-in-1 oil to lightly lubricate the two shafts of the cutting head assembly. I decided to replace the screw holding the guard with a new stainless steel socket button head because the old one was pretty chewed up. I added some thread locker and reattached the guard. Then the cutting head assembly can be slid into the gearbox housing. The large set screw is reinserted that will lock this assembly in place. Next, the linkage is attached by driving a pin into the main cutting shaft. The main pinion along with the thrust bearings can be reseated now. While we have all the grease out of the gearbox, we can see how the eccentric shaft converts the rotating force into an up and down motion on the cutting shaft. I believe this would be called a camshaft. Now we'll pack the gearbox with some Lucas Oil heavy duty grease. Back to the main housing. First we'll reinstall the switch lever and switch button. The field windings are reinserted and the wires are routed. The armature is inserted and pressed into place. Then the lower half of the gearbox can be reattached. I know here I forgot to put the plastic air redirector in, but I noticed this after I turned off the camera, so I went ahead and took the gearbox off and reinserted it. I decided to go ahead and reuse the paper seal because there were no tears and it seemed to be in pretty good shape. The two gearboxes were then married together and reattached using the socket cap screws. I'm sure some of you noticed that I missed a piece in the gearbox. I forgot to put this clip on, so we'll need to disassemble the gearbox and reattach it. It's never a good thing to finish reassembly and have pieces left over. We'll go ahead and reinsert the carbon brushes and route the wires coming off the field windings. I am going to replace the power cord, but I decided to reuse the ground wire from the existing cord, mostly because I wasn't sure if I could find a ring lug that would fit the existing screw. To connect the old ground wire to the new cord, I'm using one of these Vago 221 lever connectors, which fits perfectly in this void within the casing. The switch is reinserted and the connections from the power cord and field windings are made. The cover was then reattached. Before putting the blades back on, we'll do a quick test to make sure we put everything back together correctly. Next, the cutting blades are reattached, and another quick test to ensure we have proper clearance on all of the fasteners. Now for a real-world test, I need to cut some of this galvanized metal lathe for some concrete wall repairs I'm doing. As you can see, it cuts like a hot knife through butter. Just for comparison, this is the way that I would have done it manually with tin snips. This is actually more dangerous than using the powered shears because you need to have your hands much closer to the sharp edges. The electric shears were a tool I never thought that I needed to have, but now I'm a believer. I didn't have any scrap 16 gauge steel lying around to do a real heavy duty test. The closest I have are some 20 gauge E-plates that were part of an old transformer. As you can see, it cuts through these like it was nothing. But hopefully you enjoyed that restoration of a vintage AEG KS1.6 electronic shear. I do have at least 2 more AEG tools in the restoration pipeline, so look for more in the future. If you like this video, subscribe for more reviews of German brand tools.